Hello, good morning, and welcome to this panel on children at play, children with disabilities and play. This panel discussion that we prepared I'm quite excited about it, and we want to talk about something that's very attractive that deal with children with disabilities. And children with disabilities are often very limited in terms of their play and fun activities. And this can have an impact on their cognitive and physical development. There are many initiatives that try to facilitate and help children with disabilities to play, and they often take advantage of games to support rehabilitation for children. It's important to promote autonomy in children with disabilities and play. And all of these things have led to research in the development of very interesting initiatives. And we are lucky today to have three different approaches in this panel, approaches to play for children with disabilities. First of all, we have Teodiano Freire, who will talk about robots in social assistance and games for children with autism and Down syndrome. Secondly, we'll have Martina and Beatriz Domingo will talk about a use experience of video games at a school to help improve children's behavior. And Sandra, Espín, and Gardeazabal will talk about the use of robots as an alternative for children with severe motor disabilities. So, since we don't have much time, we're going to move right on to the first presentation by Teodiano Freire. The title is A New Social Assistance Robot with Serious Integrated Games for Therapy with Children with Autism Spectrum and Down Syndrome. He has graduated from the University of Espírito Santo in Brazil. He has also studied in the research center in Madrid. He did postdocs at the University of Alcalá and MIT in Australia. And he's a professor at the University of the Espírito Santo. He has a lot of experience in the area of electrical engineering and has been working on control systems for robots and for industrial uses. He has a wealth of scientific papers, conferences, book chapters that he has written. Let's get right into it then, and we'll give the floor to Teodiano to talk about his work. Teodiano, you have the floor. First of all, I'd like to thank the ONTE Foundation for the invitation, and thank you for this opportunity to present something that we developed at the university with our own technology to work with children that autistic children and those with Down syndrome. These are games forming part of the therapy. These are robots, games integrated in the robots. And these not only allow the children to play, but they also capture data with their cameras. And the robot will move according to the different applications and programs that we use. Our group includes master's and PhD students, many from South America, and from Colombia especially, Argentina, Ecuador, Peru. We have had students from Canada as well, and also from Italy and Holland. We've developed a number of different technologies for blind people, for artificial limbs, robotics, things for movement of so all kinds of different robotics for the elderly. Also, support for people with disabilities where they can control their environment. For domestic appliances, for example, to control domestic appliances, to control their wheelchairs as well. We try to make all of these as inclusive as possible. We've developed games for the elderly and for children, and using the Internet of Things, games that can detect movement, and we also have developments related to children with cerebral palsy. These are artificial domestic animals, wheelchairs, and other things. So this is the things that we've done in the past. And right now, we're going to talk about our new robot that we're developing. And this is developed over the last year in our laboratory. Here you can see some pictures of the robot, a few snapshots on the right side of the screen. This was built with the help of psychologists for children with autism and Down syndrome. This robot helps these children to interact with humans. It also improves the muscle development for children with problems. It introduces games, proposes games to interact with the children where they play, they can jump, they can write, and it projects the image of the game on the wall or on the floor, and then you can incorporate different attitudes on the part or different activities on the part of the child. And this is hardware and software work. So this is developed in our laboratory, and software to control the robot. It's the ROS. We use the ROS system to move the robot. And then after the game, the robot can compile and apply metrics to see if the child has executed the game properly or detects different errors. So that's it. So there's an assessment after each game. Here we also see some pictures of some of the characteristics of the robot. The robot it can be adjusted to 1.10 m to 1.40 m in height to be tailored to the height of the user. Has eyes and a mouth that move like human eyes and mouth. And the robot can move around autonomously, or it can be controlled by an adult. And at the end of each game, a report is issued that gives information on different parameters and the interaction with the child. So there are different movements that are recorded, and also different temperature changes that we can see in the child during the game, during the play. So more specifically, we use software Pygame, and the operational system is the ROS, the raw system, and hardware. There's a mini projector in the robot to project video images on the wall or the floor. For the video games, there's a laser sensor to always know where the child is, and the robot will move then according to these parameters. The robot can come closer to the child and so forth. If the child moves away, the child then will the robot will call the child and invite the child to interact and play with it. So the robot obviously has a computer on board that's going to process all of this information. So to date, we've put together more than 20 games in the repertoire of the robot. So the child, we have the child that has to walk along a rope, for example. To see, then it records the movements of the child to see if he or she is successful in walking along that rope. We have music therapy. We have dancing as well to get the children to move. We have Aladdin's magic carpet as well as one of the games. So it's a game on a carpet, and when the child then steps on this virtual carpet, it moves and responds to the and it gives the impression that it's flying. They can also play cards with the robot. And each card has a QR code, and the robot can know if it's the right card or not. Then sometimes there's games where the child has to find animals projected on the floor and so forth. So there's many different types of activities, recreational activities. You can see in the images where the robot is inviting the child to play. This is with a child with Down syndrome, and in the other picture, it's a child with autism. So in this pilot project, we started to use a strategy that wasn't working well. The children were afraid of the robot at the very beginning. So we had to kind of change the strategy of how to introduce the child to the robot. So we started, the new strategy was to have the robot already integrated into the child's environment. So after just a few minutes, the children did interact and play well with the robot in this pilot program, and the Down syndrome child was very curious to see how the robot was going to react. In the end, they wanted to keep playing. They didn't want the pilot to end. So it was a very good experience. And for children with autism, we only experimented with children with light cases of autism. And now we're working with children with medium cases, cases of autism. Now the sample is much broader. As with Down syndrome, this is used for children between age 4 and 12. And so we've done all of these tests. And the interaction does change according to the different game. And then their children are evaluated as to how well they played with the robot. We use metrics that measure how successful they were with the games. And then we have an equation which comes up with which is called a GAS rate. So the children are scored then according to their success. And at the end, we get a number. If it's over 50, that means that there was a good interaction with the robot. So in this case, the child scored a 77. This child was with autism, and so that was a very good result of the test with that child. So we did have one result, which was a -2. So with children with autism, the score then needs to be, sometimes it's a little bit skewed because it depends often on verbal communication, which is not always a possibility with autistic children. But in terms of conclusions, we developed the robots in the laboratory. So it was entirely built in the laboratory. The hardware and software was all developed, like I said, in the laboratory, using available technologies and the games as well. Then we use different parameters to use to verify the good interaction with the robot. So we showed that the robot is useful. We're now running more tests with children. And there were things, reports on television, and now a lot of mothers want their children to participate in these programs, in these tests. So we've been running tests every single day because we really have a waiting list now of parents that want their children to interact with the robots. We're going to show you a video now of children, as you can see, interacting with the robots. You can see that the mouth moves, the eyes blink and move. This is one of my PhD students there in this picture, and we show images. We put this on Instagram. And we publish a lot of pictures and videos of the tests that we run with the children. This is one of the clinics talking about the interaction. The professionals were very enthusiastic about the interaction between the robots and the children. So, with children with Down syndrome, some, like I said, scored over 77 on the interaction score, which was very good. So that's my presentation, and I'd be very happy to answer any of your questions. Thanks very much. Thank you very much, Teodiano. Very interesting. I can see we're a little bit tight on time, so we're going to leave questions until the end, and maybe we can have a discussion then near the end. Let's move on to the next presentation. Thanks again. In the next presentation we have, I'm going to share the screen here. Beatriz Domingo and Martina Eckert. The title is The Use Experience of Video Games in Physiotherapy Sessions at a School, Efficiency and Improvement Proposals. Unfortunately, I can't introduce Beatriz because I don't have information on her, but in terms of Martina, she's a telematic engineer, University of Hamburg. She has a PhD in telecommunications in the Polytechnical University in Madrid. She's a visiting professor in Madrid between 2004 and 2006. She was a teacher at the Engineering and Telecommunications School in Madrid, and she belongs to the Multimedia and Acoustic Group on multimedia systems for sustainability. She specialized in vision, image, and video, and she's researching on virtual reality now for health, serious therapeutic games, and natural interfaces for people with disabilities. So Martina will begin the presentation, and then we'll hear from Beatriz. Thanks very much to both for participating, and you have the floor. Thanks very much for that presentation. Can you see my presentation? Perfect. My name is Martina. I'm a researcher at the University of Madrid, and I'll explain a little bit what we're doing in our research, and then I'll give Beatriz the floor to talk about our experience with the video games that we developed. So we develop therapeutic video games for people with disabilities, but not only for disabled, and we focus on neurological degenerative diseases. So we have a broad scope of possibilities and needs of different people for adaptive video games. So in this case, we're talking about video games to help with physical exercises with the upper body. Ours is like an Xbox, but using a normal PC. So we focus on complete games. The idea is not to do mini games. If we want specific exercise for a specific disease, it's a virtual exercise, but it's not that different to doing this in physical therapy or virtually, and we have a more of a game approach. We try children or the participants want to win the game. So you win points and so forth during the game. Now, to apply this to everyone, both to people without disabilities as well as those with disabilities, we try to amplify movements. If they don't have too much mobility in an arm, for example, we can tweak the game so that they can still play. And then the therapist then also helps here in a web platform, and through this platform, they can see the results of the games. A little bit about the environment that we began with. Here you can see on the left the PC of the player, the child, or the person who is taking part in the game at their home or in the physical therapy session. And the internet is connected to a database that the physical therapist has. This is usually on a web page. Here's an example where you can see the results of an exercise. And this web page then reports on whether the adjustments were good or whether we need to make more adjustments. And at any point, the player executes the game at home. First, they connect to internet and then include the new configurations, and they can adapt constantly to individual players. The game that we tested in this experience is one of the first one that worked well. It's an adventure game. We have a small amphibian called Phoebe, and they need to explore a map. Now, this map is divided into cells, and each cell you decide which route to take. So here, for example, on the left, you can see a lake. When it moves through the lake, you have to do kind of swimming types of movements. At the top, there's a piece of wood that you have to cut. And on the right, you can select a different route, and there's another exercise where they have to climb a tree, so that these 4 exercises then are spread out on the map, and the player can decide which route they want to take. So in this case, we have 3 different games for arms and 1 for the torso. And it can be standing up or sitting down in a wheelchair. And the physical therapist focuses on each of these exercises wherever they want the child to do more exercise. So this is just an example, but this can be the map can be reconfigured and exchange these exercises for other things if you want. So it's just an example of how we can include different types of exercises in a game that gets you to move physically. And that's my part. And I'm going to give the floor now to Beatriz to talk about what she does.
Bien, de acuerdo.
I'll stop sharing my screen now. I'm going to begin sharing my screen now.
Sí, muy bien.
You can see it? Yes, fine. What we've done in school, we got in touch with Martina because we knew she was trying to find real environments where to perform trials of her video game. So we offer her the reality of our school and our children and our resources. We've had previous experiences with commercial video games. At the beginning, it's very attractive for the small ones. But for them, either because the movements required were too fast or too accurate, even in how to handle the game is too complicated for them. So when she started to tell us about the different adaptations that she had, or how long could each child have in order to pass on to the next screen, we realized we could adjust the game to the reality of each and every children. What we did was to select several children in our school, 6 specifically, and because of their situation, they could handle better a part of their body than others. So it was either with cerebral palsy or obstetric brachial paralysis. We did 4 weeks of traditional physical therapy, another assessment, and another 4 weeks of physical therapy jointly with the video games. And we did the final assessment. We did a functional test, Jensen test that measures how fast can children do the gestures, and another test that was what does is measure how many blocks they can move from one side to the other of the box within a minute. So we compare the variation with traditional physical therapy and the variation using the video game. And we did find positive results, but because of the limited amount of children that did this, we realized that there's a limitation to our sample. So we need to keep doing further research. Martina's project, as she said, there are many data that we can use. We checked her website and we realized that the functional variation that we found among the tests has to do with the doses of the game that the child is receiving and with the adjustments that we are doing on each of these video games. So one of the most interesting things we found when we started to do the graphs is comparing how long the child had to pass each screen, the percentage of time used, and how many trunks he or she was able to cut in that given time. We found several options. You can see here diving in orange. You can see the child spends the full amount of time, but they never reach their goal. We think this is too difficult and they get bored and they no longer want to play. With this other game, with rowing, they had very little time, but they were able to reach the other side very fast. So we might think it's positive for the child because it's too easy. But what happens is it turns out to be too boring and they don't want to play either. And then here, in climbing, with a certain adjustments, the child almost always reached their goal, but they needed a lot of most of the time that we had adjusted for them. Here is where we think that this is a challenge that is better adapted to the needs of that child at that moment. So we consider it reasonable to make a proposal for a range of adjustments to the game. So if less than 30% of the time that we allotted for the child is a game that is going to be too easy. On the other hand, if they reach less than 30% of the goals of the game is too hard, and we will need to lower those goals, and we can measure success when over 70% of time is used and over 70% of goals are achieved. So that will be a challenge best adjusted to the child. First, I would like to thank the families and the children for working with us because they were there from day one. We know we need many more studies with more participants. We need to have access to other associations or hospitals that could collaborate with us to validate these ranges, these proposals that we're making. It's important for researchers to realize that for us it's very useful to have quick access to that data that is available. That's the way we can adjust and realize if the child is motivated, and we can do a better use of the game. And lastly, video games are a very useful tool, not only for motor function, but also for integration and motivation in the school. We've been able to do activities with other classmates, colleagues, friends. They were all proposing to Martina new challenges so that they can do different things. So it's a very useful tool to to have more participation and inclusion in the school. And finally, thank you to all of you who are working in order to develop projects, games, etc., to improve the life quality of our children and their families. Thank you all. Thank you very much for this very interesting presentation. I'm going to stop sharing my screen. Great. We're going to leave the questions for the end to see if we can open up a small discussion. So now we're going to go on to the next presentation. I'm going to ask you to please not extend yourselves too much so we can have questions. This is our revision for literature regarding the use of robots for alternative manipulation for children with serious motor disability. It's presented by Sandra Espín Tello, who is a doctor in health by the University of Zaragoza, and she is a visiting researcher at Newcastle University. She is a postgrad researcher in participation, environment, and performance laboratory at the University of San Luis. She's currently a postdoc research for special needs in the Basque country. This focus on improving the participation of people with disabilities, both at home and at their community, through the use of assistive technology. Xabier Gardeazabal is a software engineer by the Basque University. He has a master in mobile computer by the Fachhochschule Oberösterreich in Austria. He's currently a postgrad student at the lab in EGOKITUZ. He's interested in assistive robotics and their adaptability, accessibility, and customization through their interfaces. He's currently researching regarding monitoring and accompaniment for seniors and augmentative manipulation for children. Without any further ado, you both have the floor. Can you hear us? Great. Hello, and thank you, Julio, for the introduction. As you mentioned, we're going to talk about the bibliography review we did on robots regarding alternative manipulation for children. According to the World Health Organization, play is a fundamental right for children. They want to, the purpose is through game to improve the participation of children in the world that surrounds them. It also promotes their independence and autonomy and learning new activities. But there are certain children that have difficulty in being able to play autonomously. That's a group of children who have serious cognitive disability. So they're restricted from playing autonomously. So basically, this prevents them from fully interacting with their environment. Since they lack this opportunity to play, this might have negative results in their cognitive evolution. So they have a difficulty to grasp objects, and that makes it difficult for them to play as their peers. So the scope is to identify the interventions that have been done so far, in what way these interventions have a consequence on their cognitive skills and their implication in the activity. So that's why we did this review. Regarding the methodology, we found in all these databases that you can see on the left, And we use a series of inclusion criteria. We look for a series of articles within scientific journals up until the year 2021, which is when we did our review. We're going to tell you about the results. We looked at over 800 articles. 12 of them came from scientific journals, 3 from conferences, and 2 from monographies. And you can see the countries where these articles were published on the center of the slide. Regarding the design of the studies, 8 were single case, 5 were pre-experimental from 1 case, and 4 were a control case. Most of the articles were published between 2011 and 2015. These were the type of robots used. 9 of them were mobile robots. There were 2 types. We have Robbie Jr., which is a remote control small robot that was used in this game. And then we have the robots that look like a vehicle. They have programmable blocks. They have a control module. And then a modular robot that can be controlled through a joystick. We also use robots with a robotic arm. 2 of them are controlled with voice-assistive technology, and the other one is remotely controlled. So you can see on the right, the robots, they use mobile arms. Some of these were mobile around their own axis. Some of them had a pincer that was able to grasp objects as well. Some were adapted through a specific keyboard. Here are the activities that were performed with the robots. Here's some of the activities we did. Transferring objects within a train, or knocking objects such as a tower of blocks, or represent a story with a robot. The activities that the robotic arms performed was grasping and leaving objects, digging them up, etc. What were the impact of these interventions? Some had to do with the cognitive skills. They were able to manifest skills they had, but they were difficult to prove that they had them. It was useful, the use of these robots to perform educational tasks. The participants showed a better performance and also a better academic attainment. Regarding the impacts of the year involvement in the activity, we saw that the level of enjoyment was increased, and so were positive social interactions. The children seemed to enjoy the activity instead of being just passive spectators. However, we have to take these results with a grain of salt, because we had a very small sample. The analysis of the results wasn't very objective in most of the studies. None of the interventions was practiced based on evidence. a revision of the bibliography only includes studies with robots that were able to manipulate their environment. And there can be other robots with the potential to mediate in children's games. Some studies might have been excluded or poorly interpreted. And as we mentioned before, the sample study was rather small. As a conclusion to our analysis, we find that it's possible that the use of manipulative robots can assist game and have a positive impact on the cognitive abilities of children with motor disabilities. And we also saw that these robots could have a use as showing hidden abilities in this group of people. Thank you very much for your other presentations, and thank you for listening to us. You have the floor again.
Muy bien, muchas gracias a vosotros y de nuevo.
Thank you to all of you and all of the panelists.
Yo considero que las presentaciones han sido interesantísimas.
I think all your presentations were very interesting, high quality research. And even though we're running out of time, I have a couple of questions for you, and I hope they're going to be short. Beginning with Teodiano.
En el robot que proponéis es que proyecta los juegos.
Regarding what games are being projected by the robots, what's the improvement of having a robot that projects the game instead of having a robot and then the games? When the robot moves around, so does the projection. So the child needs to move around to keep playing. I think the work being done by Xabier and Sandra shows clearly that we need to offer an opportunity for the child to showcase their skills, because many of those skills are hidden. So with so many parents, well, mainly mothers, they say, "Oh, I didn't know that that they were able to run around and jump around in that way. They didn't have that chance." So this highlights that the robot has a bigger improvement over static games, because specifically because it moves around, and the child follows around the robot, and they change the focus of their attention while following the robot, and also the verbal part through the pre-programmed dialogues. I think that was a great improvement. And what we said before, the children don't want to leave, they want to take the robot home to play with them. I think that has, well, a very positive impact on these children's lives. Well, I believe that when these experiences are fun for the children, they are much more successful. And this is linked to Martina and Beatriz's presentation that I think was quite exceptional, especially because it was done with a collaboration between the university and a center that deals with real users. Because sometimes we just make up the users, we don't have the opportunity to really work with them. So I would like to ask you, so the intervention of the therapist in order to be able to adjust the game to the abilities of the child, is this easy to understand? Is it accessible for the therapist, or does it need further development? I think this is a question for Beatriz. Your mic. It's easy. It's not complicated to access it. During the project, we proposed certain improvements to Martina and she added them. So we told her what we needed. And from the university, they weren't so aware of how important these things were to us. And this was one of the most beautiful aspects of this, that they were able to add in the improvements that were important to us. Great. I also wanted to ask you, are you considering some type of distribution for free or otherwise of this type of games? I guess the question is for me. Yes, of course. I don't do this just for sport. I want them to reach people. But it's not easy because we have all these prototypes. We presented the first of them. And technology has moved into a different direction. So now the same game is difficult to improve it. So now we're looking into other games. It's great to have the collaboration of private companies. So I need to get in touch with companies. And well, I would love to use this opportunity if someone is listening to us, if they want to collaborate with the university. Sometimes it's difficult because of the copyright issues, but of course, I would love to collaborate with companies. Well, I wish you all the success. And lastly, I would like to ask Sandra and Xabier regarding their presentation. The fact that they're robots that happen to be rather complex, large, and expensive. Does it limit the possibility of these activities, the range of activities? Was that mentioned in the articles that you reviewed? The difficulty to access the robots from the user's perspective. Well, that's a big limitation indeed. We think it's relevant to be able to reach as many people as possible, that this type of technology has a low-cost alternative. But this needn't mean for it to crumble apart after a few uses.
Sí, de todos modos, hemos visto en la diapositiva que hemos presentado los diferentes tipos de robots.
In the slides with the different types of projects, we had the robots with robotic arms that are more industrial style, and then the mobile robots. Well, that already lowers their price, but robotics in general is an expensive thing to use. So until this becomes more popular, these technologies won't be accessible for all. It will be great for children to have their own robot at home to be able to interact with them. Great. We're a bit over time. I hope this is not a problem for the organization. I would like to thank you all for your presentations. I think they can have a positive impact in this area of facilitating the game of children with disabilities. And this will allow them to enjoy life and have and be able to reach their full potential and have a positive evolution. So thank you. And I would like to end this session here. Thank you. Thank you. Thank you, everyone.